Reduce with prime factorization. A reduced fraction occurs when the numerator and the denominator do not share a common factor. In order to reduce our fractions, we need to find the prime factorization and divide out the common factor. So let's do an example. Example 1. A job requires 126 brackets. 85 are done. Determine the fraction of completed brackets of the total required. Write the answer as a reduced fraction. So what we can do is we can see we have a fraction. So we have the total of 126 and 84 are done. So we need to reduce this with prime factorization. This is one tool we could use to find out all the common factors, and then we can cancel them out. So if we do 84, if we look at 84 first for the prime factorization, we notice 84 can be broken into 2 and 42. Because 84 divided by 2, 2 can go into 8 4 times, and then 2 can go into 4 2 times. Then we look at 42, and we break that down further. We see that it's even, so let's just do 2. 2 can go into 42 21 times, because 2 goes into 4 2 times. 2 can go into 2 1 times. So we have 21. Then we break down 21. And we know that 3 times 7, which are prime numbers, would equal 21. And so then we are done. These are the factors of 84. Then we look at 126. Let's break this down. So 126 divided by 2. 2 can go into 126. Well, 2 can go into 12 6 times. And then 2 can go into 6 3 times. Then we look at 63. We see that it's not even, so we're probably going to have to go ahead and divide this by then 3. So 3 can go into 6 2 times, and then 3 can go into 3 1 time. So 3 times 21 is equal to 63. You can work out long division if that also helps you, but this is how we can work through it. Then we have 21, which right here, we can just go 3 and 7. So then we circle our prime numbers. We can't go any further. So we are done with the prime factorization part. Then the next part is what we can do is break down this fraction. So really 84 is 2 times 2 times 3 times 7. And then on the bottom it's 2 times 3 times 3 times 7. So those are the factors, and we do this, we use prime factorization in order to help us with reducing fractions. Because anything you see on the top and the bottom, we can divide out. Because, say, as we can say, 2 times 2 divided by 2 is just 1, or 2 over 2 is just equal to 1. So they just cross out. Then we look for another common factor on the top and the bottom. We see this 3. That can cross out because that's also equal to 1, because 3 divided by 3 is 1. And then we have a 7 and 7. We cross those out. And then what are we left with? We're left with a 2 and a 3. We can't further out divide. So we would say this is our reduced fraction because there is no longer any common factors between the numerator and the denominator, or top number and bottom number. So our solution then is just equal to 2/3. This is a way to represent 84 over 126 as a reduced fraction. Now let's do another example. Example 2. So we see that there are 40 lengths of pipe, 36 or a 4-inch pipe. The other are various sizes. Give the reduced fraction, use prime factorization for the 36 pipes out of 40 pipes. So if we were to write 36 over 40, That's our fraction. So now we're going to have to reduce this. So if we look at 36, let's do the factor tree for both of these. But 36, let's go ahead and divide it by 2 because it's even. So 2 can go into 36 how many times? Well, 2 can go into 3 one time. Then we have to, which then has a remainder. So we have to bring the 1 over to the 6. So we have 16. 2 can go to 16 8 times. Then we go 18. Well, that's even. So let's go ahead and divide it by 2. So 2 and 9, because 2 times 9 is equal to 18. Then 9 can be broken down into 3 and 3. So these are the prime numbers of 36, right? So this is the prime factorization. Now 40. Now 40 can be divided by 2, and we get 20. So if we just divide 40 in half, we get 20. Then we divide 20 by 2, we get 2 and 10. 10 can be broken down into 2 and 5. So we just go ahead and circle our prime numbers so we know that we are done because we can't go any further off those numbers, and we write out the prime factorization for the fractions. We have 2 times 2 times 3 times 3 over 2 times 2 times 2 times 5. Now, this is just rewritten, right, as our prime factorization. Now we can cross out common factors on the top and bottom. So we have a 2 and a 2. Those will cross out. Then we have another 2 and a 2. We cross those out. Then we look to see, on the top we have 3 and 3, and on the bottom we have 2 and 5. So we don't have any more common factors. We know it's reduced. So we would keep these, and then we would then multiply it out. So 3 times 3 is 9. 2 times 5 is 10. So we would say 9 tenths is the same as 36 over 40, because we took out 2 2's on the top and the bottom. Now let's do one final example. Example 3. Reduce the following measurement. We have 4 over 32 inch to its lowest terms. So we have 4 and 32. So if we were to rewrite this, well, 4 is, if we were to use the divisibility ladder, 4 can be broken down into 2 and 2. Those are the factors of 4, or their prime factorization. Then we look at 32. 32 could be broken down into 2. So 2 can go into 32. Well, 2 can go to 3 one time, carry the 1. 2 can go to 12 6 times, so 16. Then 16 can be broken down into 2. So 2 can go to 16 8 times. Then 8 can be broken down further. It's even, so we know it can be broken down to 2 and then 4, because 2 goes into 8 4 times. 4 can go 2 times 2. So we have 5 2's that make up 32 when we multiply them together. Then 4 is just 2 times 2. So if we were to rewrite this fraction, we would write 2 times 2. And then on the bottom we have 2 times 2 times 2 times 2 times 2. So we have 5 2's and then 2 2's on the top. Then next we'll just divide out the common factors. So we have a 2 here and a 2 here. So that crosses out. Then we have a 2 here and a 2 here. Those cross out. But as you can see, we are left with no more numbers on the top. So we are done. So we would say on the bottom we save these 2's, and then on the top we'll just write 1, because 2 divided by 2 is just equal to 1. So what we have is then just 1 over 2 times 2 times 2, which is equal to 8. So 1/8 is the same as 4 over 32.